Welcome to my channel. Today I'll be handling how to write chemical formula for you in chemistry. I'll teach you how to write some formulas of some compounds. So our topic is how to write molecular formula of some compound. First of all, what is a molecular formula? A molecular formula is a representation of the actual number of atoms of each element present in an atom. This is unlike empirical formula. Empirical formula is the simplest formula of a compound, showing the types of atoms in their lowest possible ratio. But molecular formula is showing the actual number of atoms of each element, not in their lowest possible ratio. And then we determine molecular formula most often from empirical formula. Molecular formula simply can be multiples of empirical formula. Now, how to write it is what I'm going to face in this video. What I mean is this: sometimes we will see somebody will write sodium hydroxide, NOH. The same hydroxide, I want to write calcium hydroxide, I have to put it in brackets. Why this bracket? I have to write sometimes potassium chloride, and when I want to write magnesium chloride, I have to put 2 in front. Now, in some cases, I want to write sodium tetraoxosulfate 6, I will put 2 in front. Then the same tetraoxosulfate 6, I want to write aluminum tetraoxosulfate 6, I have to open a bracket and write 3. So why all this? That is what I'm going to be handling in this video, to tell you when to put in bracket, when not to put in bracket, and the correct way to write each formula. Remember that if you want to memorize that this is how sodium hydroxide is written, this is how calcium hydroxide is written, there are millions and billions of compounds in chemistry. And what does this imply? You cannot meet up memorizing each compound, attaching its formula to it. It's going to be quite difficult. So what are we expected to know? Here, the basic information that we need to know to forge ahead, we must know the oxidation numbers of some compounds, oxidation numbers of some elements, especially those ones that have fixed oxidation numbers. For example, all the group 1 elements have oxidation number of +1. All the S block elements, they don't have variable oxidation states. And the S block includes the alkali metal and the alkali earth metal. That's group 1 and group 2. Group 1 and group 2 elements are all having fixed oxidation number, which are for group 1 +1, for group 2 +2. So we will work from this known to unknown. You get that now? And how do we know these oxidation states? You can also find it by their valency. So writing chemical formula will include us exchanging valencies of these participating atoms of the elements involved. Okay, so remember, this is for group 1 elements +2 is for group 2 elements. Then group 3, such as aluminium, of course, even for group 3 elements. Then when we come to group 4 now, group 4 varies. Group 4 can be +2 or +4. Then when we come to transition metals, they have variable oxidation states. Then when we come to some P block metals like chlorine, they have variable oxidation states, and that will give you possible whole numbers. So from this fixed one, we can now find the unknown. So first of all, I'll be teaching you how to write this formula based on exchange of valency. For us to know the exchange of valency, just know, as far as this topic is concerned, that the valency of group 1 elements is just +1, and therefore their oxidation and their combining power, that's the ability to form bond, their combining power is +1. That of group 2 is also +2. That of group 3 is also +3. Other groups might vary, and when they vary, this one will determine what happens when they vary. So I'm going to use an acronym. You can simply say LINAC. See? LINAC. LINAC silver. You can say LINAC silver, all +1. Lithium, sodium, hydrogen, potassium, silver all have combining power of +1. Then if this LINAC silver becomes annoyed, you can say become copper and zinc. These are common elements you will encounter while writing formula we take these ones as plus 2. That's beryllium, calcium, magnesium, copper, and zinc all plus 2. So lilac silver plus 1, become copper and zinc plus 2. There are other ones I omitted, but they are part of the plus 2. I just call those common ones that will help you. I'm giving you the valencies and also the combining powers. Then oxygen in all compounds is usually minus 2, except in peroxides. So in peroxides, oxygen is minus 1. So hydrogen is included here, is plus 1. So hydrogen is plus 1 in all covalent compounds. But in electrovalent compounds, that's ionic compounds, hydrogen, this same hydrogen can be minus 1 as hydride. For instance, when it combines with metal, here hydrogen is assuming to be what? Minus 1. But in any covalent compound, the oxidation state assigned to hydrogen is plus 1. Then chlorine in chlorides is seen as minus 1. So chlorine in, this is what we call chloride ion, is minus 1. So with this basic information I've provided, we will be able to write the formulas of different compounds when they have given us the IUPAC name. Okay, so let's proceed. Now let us make use of writing formulas by exchange of valencies between the atoms of the elements involved. For example, Eg1, how do I write the formula of sodium chloride? First, I have sodium, I have chlorine. What I'm going to do is I write sodium here, I write chlorine here. Then you do what? You just make this structure. Under sodium, what did I tell you? That sodium is part of those ones, lilac plus 1. That's lilac silver plus 1. So sodium is plus 1. Chlorine in chloride, because they say chloride ion is minus 1. This is already known fact. So minus 1 is for chlorine, plus 1 is for sodium. Now we are going to take that of sodium and give it to chlorine, and take that of chlorine and give it to sodium. Let's go. It becomes Na minus 1 and Cl plus 1. Because minus 1 plus 1 is automatically 0. Therefore, we are left with what? The formula is NaCl. Because NaCl means Na1 and Cl1. Nobody writes 1x or x1, unless if you want to differentiate it from the other ones that are x2. So this is the formula for sodium chloride. In other words, we exchange valency without exchanging the charges. So we take a look at another example. Example 2, let us write the formula of aluminum chloride. Aluminum chloride. The same chloride. So I'm going to change sodium here to Al, which is aluminum. And the valency of aluminum, because it's in group 3, is plus 3. This remains minus 1. So what am I going to do? I will take that of chlorine to aluminum and take that of aluminum to chlorine without their charges. Please neglect the charges. So let's go. That means Al is 1, and if it is 1, you shouldn't write it. Cl will take 3, becomes Cl3. So this is the formula for aluminum chloride. Okay. So example 3 is aluminum oxide. Aluminum oxide. So I'll only clean here and now add oxygen. Remember I told you that oxygen is minus 2 in all organic compounds. These are basic facts you must know for you to write formula as well. So I'll put minus 2 here. Aluminum is plus 3, it remains. This is not what I'm writing. I'm now writing against the oxide. Let me clean up this. So aluminum, that means this 2 for minus 2 for oxygen goes to aluminum. and 3 for aluminium goes to oxygen. Forget about the charges, that's minus or plus, don't put them. So when I write aluminium, instead of writing the 3 that belongs to aluminium, we have to exchange the valency. That means 2 will be here, and the oxygen will take the 3 that belongs to this. So this is the formula for aluminum oxide. Okay, now the next example is, let us take a look at calcium oxide. Example 4. How do you write the formula of calcium oxide? In this case, calcium, I will replace this aluminum with what? Calcium. This, I've been giving you examples in what we call binary compounds. So Ca is here. So what's the state for Ca? Plus 2. Okay, I have to clean up this. Now, over here, what will happen? There will still be. So, for you to write calcium oxide, here we have 2 and 2 different signs. Remember, I told you to write them without the sign. So, we have Ca2O2. But because they are equal, you cancel out, so that we are left with CaO. This is the formula for calcium oxide. I've been giving you examples on how to write binary compounds. Now, let's take a look at on how to write the molecular formula of ternary compounds, meaning compounds that are made up of 3 elements. Okay, let's move into that quickly. So writing ternary compounds, let's take a look at example 1 under ternary, meaning let's assume we want to write sodium trioxocarbonate, carbonate 4. Let me put it here, carbonate 4 IV. Okay, this is ternary. So one should learn these basics. If we have A, B, C, 3, this means A try C, you call A to the fullness, jump B, call the number here. If it is 3, you say try. If it is 4, you say tetra. If it is 2, you say di. If it is 5, you say penta. If it is 6, you say hexa. If it is 7, you say hepta. Okay, so A, B, C. So you call this A, jump B, and call this number try A, try C, B rate. This is where now you attach it. So when we attach this, sodium is our A, the carbon is our B, and the oxygen, oxo, is our C. And they say try, that means it's going to be 3. Your job is to write out Na, which is the first, because I told you the trioxo shows the last. You say 3 and carbonate. So it is assumed that it is NaCO3. Then check if your formula is wrong or right, because unfortunately this is incorrect formula. All right. So how do you check if your formula is wrong or right? Having told you already that sodium is +1, we want to check because there is no charge here. When there is no charge, it literally means that when we calculate the sum of the algebraic sum of the oxidation number of 1 atom of sodium, 1 atom of carbon, and 3 atoms of oxygen, that it will give us 0. But if it didn't give us 0, that means the formula is incorrect. Okay, if there is a charge here, it will also give us the charge here. If there is -2, we sum up everything, it will give us -2. But this is neutral compound. Okay, so sodium is 1 plus, they have told us carbonate 4, which means carbon here is 4. 1 carbon exists for them. I've already told you that oxygen is -2. So -2 times 3 is -6. So what do we have? 1 plus 4 minus 6. Because plus minus is still minus. What do we have here? We have -1. That shows this formula is incorrect. Remember what I told you? If it gives us 0, that shows it is correct. Now, your job is, what do you add to 1? What do you add to -1 to make it 0? Because we want to make it 0. What must be added to -1 to give 0 is +1. So which means you have to increase the electron that is donated here by 1 so that they will neutralize out. So, and sodium brings 1. So it means that we needed extra sodium atom plus the one that is here, so it should be 2. So that's how to know it. If you now write Na2, when it gives you minus, when the sum total gives you negative, you go and increase the number of positive ion you have. Sodium is the only one giving us positive. So if you now increase it by the number remaining, like if I have -2, I'll go and add to already existing sodium. It will now be 3. But if I have -1, I'll go and add 1 to the sodium I already have. So I already had 1 sodium plus that one gives me Na2. So check this. If it is 0, this is now 1 sodium is plus 1 times now 2 plus 4 times 1 because carbon is only 4 plus -2 times 3 -6. Let's check. Here becomes 2 plus 4, which is 6. Then -6 is 0. So this is the correct formula for sodium triisocarbonate 4. Okay. So the correct formula for sodium triisocarbonate 4 is 2 plus Na2CO3. Okay. We move to the next example, example 2, in writing ternary compounds. Let's take a look at, if we want to write aluminum tetraoxosulfate 6, example 2. Be careful, VI and IV. IV is 4, VI is 6. So just like I told you, we have tetra, which means oxygen will be 4 atoms. So to give us, you write first of all the neutral, that's the basics, and check if it is correct. We are going to write Al, then we go and write O4 because that's what it means, okay? Tetra, oxo, that's tetra, oxo. Sulfate, you write sulfur in the middle. So this is AlSO4. Check. Let us check if it is correct. Aluminum, I told you earlier, is +3. So let's go. +3 is the only one aluminum here. Times 1 is still +3. And what is sulfur here? The name have already said sulfate 6. If the name says sulfate 4, we will now take sulfur here as 4. Sulfate 6, that means 1 sulfur here is 6. If there should be 2 in front, that will be 6 times 2. But 1 sulfur here is 6 because the name indicated it, plus -2 times 4 because 1 oxygen is -2. So that 4 atoms of oxygen will be -2 times 4. Let's go. This is 3 plus 6, of course, -8, which gives us what? +1. In the example 1, we got -1. This time around, we got +1. If you get +1, don't go increasing the cation. If I increase the cation by adding extra 1, so that aluminum will become 2, it will worsen the whole thing because here will now be 3 times 2, which is 6 plus 6, which will give me 12 minus 8. So the number keep increasing. So when it gives you positive number, see what you're going to do. Remove the metal and group the other one. So you're going to separate them now into, just look at the only metal present. I'll separate it into 2. This is, I've grouped this into group A and B to help me write it correctly. Okay. So when I group this, I'm going to keep aluminum away because I already know that aluminum is +3. So SO4 as a group, what is the net charge? Remember the name says 6 and oxygen is -2 times 4. This is -8. So 6 minus 8 is -2. Therefore, this as a group will have 2 minus as a net charge. That's why when you see the right SO4 2 minus, it means it has to gain extra 2 electrons to become stable. So that means this SO4 as a group have -2. Aluminum now already have +3. Okay. Aluminum have +3 already. So having divided this into 2, remember what I tell you, when it gives you positive, you group, remove the metal and group the remaining 2 non-metals. So I'm going to now go back to exchange of valency. This is SO4 now. I will separate them. Under aluminum, I'm going to write what? +3. under this as a group minus 2, because that's the net charge I got. 6 minus 8 is minus 2. Then let aluminium take that of tetraoxosulfate 6. Let tetraoxosulfate 6 take that of aluminium. Exchange of valency. I'll now write Al2, but watch it. If I write SO43, it becomes SO43. To tell you that this SO4 as a group is taking the 3, I'm going to put it in bracket. That's the correct thing. So this is the correct formula for aluminum. Now, check. When we check this, did it give us 0? Actually, let's check if this formula really gave us 0 as a net charge. Yes. Remember that aluminum is 3. 3 times 2 is 6. Now, sulfur is sulfate 6. And the 6 of them, how many? When we have sulfate 6, 6 times 3 is going to be 12. Then oxygen is minus 2. Minus 2 times 4 is minus 8 times 3, which means we just say 3 times 4, which is 12. 12 times 2 is 24. So 6 plus 12 is what? 12 times 12 times 2 is 24. So then 6 plus this is now taking us to the answer. 3 times 4 is 6. Then sulfate 6. So no, this is 18, please. 3 times 6 is 18, because they say sulfate 6. So 6 times 3, 18. So 6 plus 18 is 24. 24 minus 24 is 0. So this is a correct formula on the check. All right. Now, try your ability. Can you write calcium tetraoxophosphate 5? Calcium tetraoxophosphate 5. As I move to quaternary compounds, how to write the formula and also how to name quaternary compounds. Quaternary compounds are compounds made up of 4 elements. So the binary have 2 elements, ternary have 3 elements, quaternary are those that have 4 elements. So try your ability. Use that comment section there to give us our classwork. Try to work it out by yourself. Don't go and look it up in the internet. Write the formula of calcium tetraoxophosphate. Now, phosphate 5. Please, maybe I put it down here. Phosphate 5. Calcium tetraoxophosphate 5. Telling you that the phosphorus there is 5. So give us the answer in the comment section. Then please subscribe and share this video. We move to the quaternary compounds.
Learn science for free with Sir Majesty Easy World Science. Master chemistry, biology, and physics on our YouTube channel, where we offer comprehensive tutorials, exclusive science practical demonstrations, real-world applications of scientific knowledge to solve environmental and human challenges. We also specialize in building and equipping science laboratories with quality and reliable services. Call WhatsApp +234 706 516 6217. Join us and elevate your learning experience. Stay majestic.